All right, I will show you the screen. So before going to the last part, what is the question? All right. So our last part is about the reliability analysis, how to check the reliability, how to compute the composite variable, how to do the descriptive statistics, and then there is a drill for you. So for reliability analysis, I will go to my data set, go to analyze button, and you have an option of scale. I am again repeating, go to analyze button, and there is an option of scale under the dimension reduction. There is an option for scale. You just need to click reliability analysis. Remember this that reliability analysis is done with your statement, your factors or construct. Like I would like to see how my first variable like MB1, MB2, MB3, MB4, this is related with my first variable, which is basically mobile banking. If I show you the questionnaire, this is mobile banking, MB. So MB1, MB2, MB3, MB4. Let's suppose this is my first variable, mobile banking, where I would like to check the reliability of my variable. So how can I do it? Simply select all these four and put it over here, because they are showing the one category of factors. You simply need to click OK button, and it will show you these results. If you can see the reliability analysis score, I would like to copy from here and paste here so that you may easily see what score we have obtained over here. Cronbach alpha is 0.878 with 4 items. It means that mobile banking, the construct of mobile banking with 4 item is reliable. How I came to know that it is reliable? Because according to Hire et al., if the value of Cronbach alpha, if the value of Cronbach alpha is greater than 0.70, it means that your construct mean that your mobile banking construct or mobile banking variable. So your mobile banking variable is basically reliable construct. In the same way, you can check the reliability of others. Sir, please add me to the WhatsApp group. All right, I will add you after completing this session. All right. Next one, you can check the reliability of other variable in the same way. Like I go to the analyze, go to the scale button, reliability analysis. I can choose the other, but before choosing other, we need to draw the previous one from here, and then we need to choose the other variables from here, put it, then select OK button, and you can see their values of reliability. I can put it over here. You can see it, the Cronbach alpha value of it is 0.896. It is also greater than 0.70. It means they are reliable. So according to Hire et al., the value should be greater than 0.70. So how can I interpret this is actually ATM facility, because the name of the variable was AF1 to AF4. So according to my questionnaire, it is ATM facility. So I can say the construct of ATM facility is reliable. The construct of ATM facility with four items is statistically reliable. Statistically reliable. All right. Again, you can also put it here, and you can also put here some reference as recommended by Fire et al. 2020. You can put some reference so it will become much more formal, much more academically acceptable statement. So in the same way, you can do the reliability analysis of other factor also. So what we do if the reliability of some of the variable is not good? Let's suppose I would like to see the reliability of some other variable, but in this data set, all of the variable are good. So what we do if the reliability of some of our variable is not good, means if Cronbach alpha is less than 0.70, so we need to check which factor or which statement is basically causing this reliability to go down. So there is a procedure. Go to the analyze button, go to the scale reliability analysis, and for example, if I would like to check which of these factor is causing the reliability to get lower, you can select the statistic option, and you can select the scale if item deleted. It will show you which item or which statement is causing a less reliability. Just click continue, just click OK. It will show you not only the reliability, but also it will show you which item may cause a lesser reliability. If we can see that if we delete AF1, the reliability will be this. If we delete AF2, the reliability will increase to 0.866. But if we delete AF3, the reliability will decrease. If we delete AF4, the reliability will be 0.864. So if your reliability of your factors is less than 0.70, you can perform this analysis in order to see which factor is causing the reliability to decrease. Just you need to decrease that factor or delete that factor, or you can also do that. For example, if I consider to delete AF1, the reliability will be this. So if I go to the analyze button, I select the reliability analysis, I put it side and click OK button. It will show me the value of reliability like this. So this analysis will let you know that which factor must be deleted to obtain a required level of reliability. So I hope that you will understand how to check the reliability of factor. How can you remedize if reliability is not good? Next is composite variable calculation. How you can compute a variable, because there are a lot of factors in your data set. Like I didn't have created a mobile banking variable. I have four factors of mobile banking, because when I see my questionnaire, there is a construct name mobile banking, and there are four statements. So MB1 to MB4 are representing my four statement. MB1 is my statement 1, MB2 is my statement 2, MB3 is my statement 3, MB4 is my statement 4. So how can I compute the composite variable? So there is a way to compute a composite variable. You need to go in the menu bar and you need to click on the transform button, and here is compute variable. There are two ways to compute a variable. Mostly the researcher used the first way, which is mean based variable method. What is the justification if we delete any item and then reliability will greater than? If you have a lot of factors, like in my case, I have only three or four factors, and if my reliability is less than 0.70, and if we need to decrease two items, and it will increase my reliability 0.70 or greater, it you need to tell in your interpretation that due to reliability issue you need to delete some of the items from your variable, and it is the only justification, because you need to verify whether your construct is reliable or not. So with the number of factors your construct is reliable, it will be considered a reliable construct, and it is the only justification that you need to put. All right. How to calculate your variable? For example, I want to create mobile banking. As I have told you earlier that you cannot put uh, the two words name of a variable. However, you can create a hyphen between two words, like I want to create mobile banking with a hyphen, and the mobile banking variable will be created on the basis of these four factors: MB1, MB2, MB3, MB4. So there are a function, there are a lot of function over here. You need to choose from functional group statistical, and you need to choose mean by double click. When you double click, this option will appear over here. You just need to double click on MB1, it will appear here. You need you need to put a comma after it, and you need to double click MB2. It will, just a minute, MB2, double click, then you need to put a comma over here. You need to double click MB3, you need to put a comma over here, then you double click MB4, MB4, yes, then you close the bracket and click OK button. When you click OK button, it has computed your composite variable. Like if we need to verify it, you can see in the data view by scrolling horizontally from left to right. You can see here your composite variable was computed. Someone asked some question. If an important factor is not reliable, then what should we do, because we don't want to remove that factor? All right, Dr. Ubaid, basically, if an important factor is not reliable, the first suggestion is to increase your sample size. Maybe with increasing the sample size, the reliability issue is resolved. Sometimes we have a lesser sample size. We have some of the observation due to which we are unable in the estimation procedure that it will not become reliable. If the factor is important, then my suggestion is to increase your sample size. Hope this will be the answer. All right. In the same way, you can compute the other variables. In my case, I have ATM facility variable. In the same way, I can estimate this variable. I go to analyze, go to the transform, compute the variable. ATM facility, put a hyphen when two words name is required. Again, you need to delete the previous one, but remain the formula should be remain intact. And ATM facility, double click AF1, comma, double click AF2, comma, double click AF3, comma, and double click AF4. Just need to click OK and you will compute your second variable. In the same way, you can compute the other variables also. So here is the composite variable procedure. If the sample is rare and difficult to increase, then is there any other suggestion? Uh, Basically, reliability matters when you are doing a primary data study. But if the sample is rare and cannot be increased, then you can check the reliability by other methods. Like you can check for its composite reliability, you can check for it average variance extracted, like structural equation modeling. You need to perform SEM estimation technique, which would be available through Smart PLS. So the Smart PLS has a option that it will estimate and it will bootstrap your estimation with the small sample size. So hope it will be the answer. So I have done composite variable computation. The next one is descriptive statistic of your computed variable. How can you compute the descriptive statistic? It is the last one, so don't get worried about it. You need to go to the analyze button, go to the descriptive statistics, go to descriptive simply, and you need to uh, you need to basically calculate the descriptive statistics of the composite variable actually, not the demographic in this way. I have selected the number of composite variable that I have computed over here. Go to the option bar and just put what you want to compute over here. Like in most of the cases, people need to compute mean, standard deviation, minimum, maximum, kurtosis, skewness, continue, and OK button. You will compute the descriptive statistic table over here. Just copy it and paste it. Yes. So this is basically the descriptive statistic which you can compute from the composite variable. What is how to identify that data is manipulated? All right. Data manipulation can be identified by seeing the data itself. You need to see the direction of the responses. Sometimes the data manipulation by a human. There are a lot of latest techniques that can be applied with R, Python to manipulate the data. But sometimes when a human manipulate the data, like copying and pasting the number of observation, so you need to check out through the direction of the data whether it is manipulated or not. Uh, in a human manipulation, the result will be different from actual or desired results. If the respondent has responded your questionnaire in a mature way, in a understandable way, your the direction of your hypothesis will be confirmed from the estimation. But in most of the time, when the direction of your hypothesis is not confirmed from the estimation of regression results or some other means or some other estimations, you can say that the problem of data manipulation is there. So here can you explain the skewness and kurtosis part? I mean, how to interpret it, because I have read multiple interpretation and still it confuses me a lot. Yes, I can interpret because this is the last part. Uh, Come to the skewness part. Yes, I will arrange this table. I will select the layout in a better way, like orientation in the landscape mode. All right. Now we can see the complete table. You can see the minimum, the maximum statistic minimum is 1.25 and maximum is 5, while the mean value is indicating 3.6. If we uh, if we round off the value of mean, we can say that it is approximately 4. On the scale side, in on the Likert scale, 1 mean strongly disagree, 2 means disagree, 3 means neutral, 4 means agree, and the fifth means strongly agree. So we can conclude over here that majority of the people are in between 3 and 4. Either they are neutral or they are agree. But if we round the values of the mean to their nearest digit, we are going towards the agreement that most of the people are stating, or on average, the people or the sample people are stating that they agree with the statement of mobile banking, they are agree with the statement of ATM facility. uh, while the standard deviation is like, if we round off them, uh, it is indicating the strongly disagree. Okay, let's come to the skewness part or kurtosis part. Skewness and kurtosis are used for normality purpose, whether your data is normal or not. There are different interpretation, and you need to understand the basic criteria how we consider the skewness and kurtosis. There is one interpretation which states that kurtosis should be between +3 and -3, in between +3 or -3, and in the similar way skewness should be +1, between +1 and -1. So if your skewness value lies between +1 and -1, it means your data is normal. In the same way, if your kurtosis lies between +3 and -3, it means your data is normal. In our case, if we see, our skewness values are between minus and +1. And in the same way, if we see the kurtosis value, these are also between +-3. It means that both the values are normal. How to check the validity of your data? For checking the validity of data, there is a procedure named structural equation modeling, because in next couple of weeks, I would let you know how to check the validity. There is convergent validity and there is discriminant validity that we will check over there. If the values are not in range, then what should be our next step? If the values are not in range, then obviously we need to check whether it is manipulated data or not. And if your data uh, has a lesser sample size, like in my case, if it has lesser number of observation, you need to increase the sample size to make it better or make it valid.
Basically, I'm asking about skewness and kurtosis, as you have said that this is the criteria. And what if our values are not in range? I'm talking particularly talking about skewness and kurtosis part.
If
Obviously, we won't be getting any normal data, right? So, what would be our next step? Should be like you? Is there any kind of method to make it correct, or what?
Yes, there are a lot of methods available, but at first we need to increase the sample size. If due to any case, if we could not increase the sample size, then we need to check the values whether there are some missing values or some other problems within the data. We can also take the average of the data. We can also change the measurement style of the data, like I computed the composite variable using mean. You can also check for composite variable using median. So technique, changing the technique will obviously resolve the issue. But I personally recommend using if your data has a problem, if your data has a normality issue, you can still estimate your hypothesis. You can also test your hypothesis using smart PLS, partial least square method. So method is available. Any other question? Is there any question further? So here our session is completed. We have completed all the process of today's discussion. Uh, I will share a data set with you, questionnaire with you. You need to apply the process. Just take a screenshot. Uh, what I want to require from you to apply the next step. Like I would like you to apply. First of all, you have completed this drill, drill one. You have completed, you have created code book, you have selected your level of measurement. Your second drill was, this was your second drill. Sorry, this is not this. Can you hear me?
Yes, sir.
All right.
Yes, sir.
So your mic is off.
All right. I repeat again. Basically, you have two drills to complete. The first drill is that you have 10 minutes to complete the following task. You will be provided a data set. You need to analyze the missing values using SPSS. You need to summarize the demographic summary like I did. You need to make some cross tables. Then the third drill is you need to check the factor reliability. You need to compute your composite variable, and you need to estimate the descriptive statistic. So take a screenshot of these both drill second and drill third. So you need to perform these two steps, and if you need, if you face any problem, you need to discuss in the WhatsApp group, and we will consider the tomorrow section in more advanced way in some other contents that we have not discussed today. So if you have any question, you may ask. All right, participant, I think we have done a lot today. I hope that you people didn't get bored from this training session, and you have enjoyed a lot learning these skills at basic level. As far as the time passes and the day passes and the session passes, we will move towards the more advanced skills. So we will further discuss the more technical details, the further details and more technical contents in tomorrow's session, and I will share the link also. Thanks a lot, and be safe and be happy. Thanks a lot.